Welcome back. Today we will learn the equivalent frame method of solving flat slabs. Here the basic assumptions include the bending moments and shear forces may be determined by an analysis of the structure as a continuous frame, and the following assumptions are made. So as I told in the previous class, in the case of equivalent frame method, we are analyzing the frame directly and we are getting the required result. The direct strength method or direct design method, if you remember, there were some Codal provisions which directly give the values by which you can get the design moments. So the basic assumptions include the structure shall be considered to made up of equivalent frames on column lines taken longitudinally and transversely through the building. Each frame consists of a row of equivalent column supports bounded laterally by the center line of the panel on each side of the center line of the columns or supports. Frames adjacent and parallel to an edge shall be bounded by the edge at the and the center line of the adjacent panel. Each frame must be analyzed in its entirety, and for vertical loading, each floor thereof and the roof may be analyzed separately with its columns being assumed fixed at the remote ends. So it's like the substructure approach when we will analyze as a columns top and bottom fixed, where the slabs are thus analyzed separately, and it may be assumed in determining the bending moment at a given support that the slabs is fixed at any support two panels distant therefore, provided the slab continues beyond the point. For the purpose of determining the relative stiffness of members, the moment of inertia of any slab or column may be assumed to be that of the gross cross-section of the concrete alone. Variations of moment of inertia along the axis of the slab on account of provision of drops shall be taken into account. In the case of recessed or coffered slab, which is made of solid in the region of the columns, the stiffening effect may be ignored provided the solid part of the slab does not extend more than 0.15 times the L effective into the span measured and from the center line of the columns. The stiffening effect of the flared column heads may be ignored. So these actually assumes how to select the frame from a multi-storied building, and also on the calculations for stiffness, especially on the columns as well as the slabs. So these are the assumptions upon which we are analyzing the current frame. And in the case of loading pattern, when the loading pattern is known, the structure shall be analyzed for the load concerned. And this table 17, it belongs to the previous direct design method. When the live load is variable but does not exceed 3/4 of the dead load, or the nature of the live load is such that all panels will be loaded simultaneously, the maximum moments which may be assumed to occur at all sections when full design live load is on the entire slab system. Then comes for other conditions of live load or dead load. ratio, and when the panels are not loaded simultaneously, the maximum positive moment near midspan of a panel may be assumed to occur when three-quarters of the full design live load is on the panel and all the alternate panels. The maximum negative moment in the slab at a support may be assumed to occur when three-quarters of the design live load on the adjacent panels. And the close 31.5.3 is on the negative design moments, which we have to find because in last uh, design procedure these values were directly given as 0.65 and 0.35. So how to consider the negative design moment, what should be the length to consider, and how to modify the maximum moment, then distribution of the bending moments across the panel with column strip negative moment uh, at an exterior support, then a column strip positive moment for each span, moments that acts on the middle strip. So these moments are given, in the sense the directions are given to analyze for the moments by the substructure approach. So after analyzing the moment, we can directly design for the individual structural elements. Then the shear in flat slab, as we discussed, the shear will be predominant at a distance of d by 2 from the surface of the column face or even from the drop panel as listed here. And how to calculate the shear stresses? We know the position at which shear is occurring, and by calculating the acting area, we can find the shear stress. Yeah, this was we discussed support section at a distance of d by 2 from the support. We have the critical section. For circle also, it will be d by 2 distance from the outer periphery. So for different types of columns, it is discussed here. For cross columns, d by 2 from the farther end, and for L-shaped for other sections. So this shows the critical sections of the shear where we have to analyze. When the unbalanced gravity load, wind, earthquake, or other forces causes transfer of bending moment between slab and column, a fraction 1 minus alpha of the moment shall be considered transferred by the eccentricity of the shear about center of the critical section. Shear stresses shall be taken as varying linearly about the centroid of the critical section. Value of alpha shall be obtained from the equation given in 31.3.3, which we discussed in the direct strength, so direct descent method. And 31.6.3 is on the permissible shear stress. When the shear reinforcement is not provided, what should be the calculated shear stress? And, so this were the diagram showing the critical sections and also some openings if it is available in the or if it is provided in the flat slab, what are the changes happens to that. This case modification factor is given by zero point 0.5 plus beta c, but not greater than 1, beta c being the ratio of short side to long side of the column capital, and tau c is equal to 0.25 root of ck in limit state method of design. When the shear stress at the critical section exceeds the value of 1.5 tau c, shear reinforcement shall be provided. This all things are known to you regarding the provision of shear reinforcement. Then the slab reinforcement, spacing of bars in flat slab, all are given here. The area of reinforcement when drop panels are used, there should be a thickness of drop are given, then the minimum length of the reinforcement. So this is something we will check again once we are doing the problem for a clear understanding. And some guidelines on the anchoring reinforcement. And so for anchor reinforcement, the minimum anchor value for the reinforcements are given. Similarly, for the negative reinforcement and positive reinforcement. Then regarding the provision of openings in flat slab, so openings of any size may be provided in the flat slab if it is shown by analysis that the requirements for strength and serviceability are met. However, for openings conforming to the following, no special analysis required. So these things is permitted in the flat slab even after the design. So these are the various Codal provisions which they are related to the equivalent frame method. So please go through these uh, clauses and understand it better.